So I want to talk about something different, clusters of water molecules with 2 plus and 3 plus charges. I was looking up a scientist called Anthony Stace. Published this back in 1988. So you got so this was in Physical Review. So when n is minimum of 35, it's stable size, or minimum 36. That's minimum stable size. So N 3 plus and H2O N H3 3 plus. Okay, so these are two other ions which Stace discovered. Cluster of so water molecule cluster with its 3 plus charge, triple charge, and a one with which is protonated with triple charge. Also, so when you have n is near the minimum size to these, so 35, 36, this version dominates. So if they're near the minimum, that dominates, the protonated dominates. Okay. But when n is greater than 70, the this dominates. Okay, so you got H2O, say 71 or higher, dominates. Okay, so in the ions, these could have the configurations. So this one and that one, respectfully. So this configuration like that, and that configuration like this in liquid. The N, I think, refers to the 35, 36. And H2O T plus has form. This is so H2O N minus 4 dot H3O plus OH2. Okay. So this, I think it's these ions that actually the H3O here, these actually stabilize the structure of the hydrogen bonding. Stabilize. These stabilize. So this has the form. So this is the oxonium ion H3O plus. This is something called. So yeah, so you got this H2O N times 2 plus is the form. It's got configuration, so that means the molecules will be arranged as H2O N minus 4 times. So I think the H2O is referring to 35 In this case, there's no proton, so it'd be referring to B36. And then you've got, it'll be referring to 36. So 36 minus 4 is 32. And then you've got H3O oxoniumine to hydroxide, which is a this is kind of like there's a proton transfer process that occurs when you get hydroxyamides transferring to protons. It's something called the Grothus mechanism in physical chemistry, which is a bit like this. You get protons transferred from one molecule, water molecule to water molecule to water molecule, something called the Grothus mechanism. And then when you get a proton, it's protonated, so in this case it's N is minimum 35, so you get H2O and H3 plus. This is protonated though, unlike that one. So the whole of this thing is charged 33 plus. This is the configuration H2O N minus 5 times attached to the hydroxyamide of this twice, and then another hydroxyamide, oxoniamide, sorry. So that's, and then you get and then you get what do you get next? Then you get two other possibilities. You get H2O and H2 plus. So this is, I think Stasis speculates is this structure. And you get this. So this is doubly charged and this is triply charged. So I think he's speculating that based on data and evidence, and I think combination of experimental evidence and spectroscopy evidence, and well, but that's experimental, and also calculations, he's speculating this has the configuration plus, no, it's twice, okay? That's 2 times that one. So H2O N minus 4 times. So with this protonated, it's probably minimum N 35 molecules. This is 3 plus, that's 2 plus, triply charged. I think what Stasis paper is reporting is the first triply and doubly charged clusters of water molecules. He's his first ever reporting of it. Is for configuration water N minus 4 times, and then this proton transfer, and then 2 oxoniamines. But this, but these do not seem to be stable. I thought that was interesting. So you get multiply charged clusters with unprotonated ions need the charge that's present. So yeah. And then he's mentioning also about doing work in sort of H2O 57, sorry, 57 C plus and H2O 57 implementing 3 plus. Yeah, 3, and also he talked also about quadruply charged, but there's, I don't think he's done much in that. So yeah, this is yeah, these didn't seem to be stable, but there are 2 other possibilities. Probably calculations showing they're not very stable. Also, maybe they don't live very long in experiments. But yeah, these are this is that form, and that is that form. This is, these 2 is that form, sorry, what am I doing here? That is this configuration, that ion is this configuration, and then so, and this is this form, and this has this form. That's actually, that's not the same as that though, and this is not the same as that. But yeah, this is basically work done, Anthony Stace. Published in Physical (1988). It's a long time ago. I've not been able to find any more recent work on this. Can't find anything further. It's been cited, but I haven't been able to find any further work, so I don't know. It's new discoveries he made. I was going to, there's other papers he's done in benzene I'm going to make videos on. So, but these were first observations of doubly and triply charged ions. These are first observations of them, and the confirmations. So yeah.